Pretty good. How you doing?
Pretty good. Feel a little under the weather, but
Yeah. So you got a math test next week.
yes, I do.
Okay.
And it's all on like sine, cosine, cosecant, stuff like that.
Okay. Trig.
Cotangent, stuff like that. And the reason that I had to reschedule last night is because the teacher hasn't posted up he didn't post up the review sheet that I wanted to do with you.
Okay.
And I checked this morning and he still hasn't, so I sent him an email a few minutes earlier this morning, and
Okay.
he replied back and he said that yeah, he can get it like this afternoon, maybe tomorrow morning, up on his website. So I don't have anything to work with with you this morning, but I was wondering if maybe you could actually like give me like a brief maybe lesson or something like that. Anything you have on like cosecant stuff.
I definitely can. First of all, how long have you been on trig?
Well, it's been this whole year.
Okay. You didn't do a semester of pre-calc?
Oh yeah, pre-calc was last semester and trig is this semester.
And trig is this semester. Okay.
Yeah, they just put it all together and call it pre-calc trig. So.
Yeah, no, that's fine. I was just curious how deep into it you probably are. What's the last thing you remember working on in trig?
Right now we took a little quiz the other day on what was it? It was like the comparisons between it was like in the equations. We had to match the equations. I actually do have that sheet of paper. Let me pull it out real quick. I can tell you exactly what it's called.
Okay. I can give you a little bit of a primer.
All right. Well, this thing was called, let me find it real quick, like the fundamental, the trig identities.
Okay.
So like the quotient identities, Pythagorean, double angle, negative angle, yeah, stuff like that.
Okay. Well, we can go
That was
over
the last thing we were working on.
We can go over that. First of all, tell me what the sine of theta is in this triangle.
$30.
Okay. A trig function of an angle is equal to a ratio.
Oh.
So it's always going to be one side over another side. Let's start with SOHCAHTOA. Some of this stuff is just absolutely fundamental to trig, and you just have to learn.
Yeah.
So the SO of SOHCAHTOA means what?
Sine of opposite over hypotenuse.
Okay. The CA?
Cosine of adjacent over hypotenuse.
And the TOA?
The tangent of opposite over adjacent.
Okay. So what is the sine of theta in this triangle that I've drawn?
Sine of theta would be equal to 1 over 2.
Okay. So that's actually the sine of 30 degrees. I replaced theta with 30 degrees because this is a 30-60 triangle. So the sine of theta...
Yeah, that's why I said 30 earlier.
So what is the secant of 30 degrees?
That I don't know. I don't remember how to do all the the secant stuff. That's what I've been having troubles with, is how to do like all the other properties of it. So the secant, cosecant.
A lot of trig is memorized.
Yeah.
And with memorization, I can give you some secrets, not secrets, but tips. But here's the main one. Here's your 3 primary trig functions that are on your calculator.
Yeah.
Okay? They're actually no more primary than the other 3, but they're the ones listed on your calculator. I tend to do everything in sine, cosine, tangent, and then if they ask about secant or cotangent, I look at the reciprocals. So first of all, we need to know which of the other 3 are reciprocals of each of these. there's 1 to 1. What's the reciprocal of tangent?
Cotangent.
Okay.
So we 1 over cotangent.
Now we only have 2 left, secant and cosecant.
So it'd be, secant would be equal to sine.
No.
It'd be 1 over secant.
It's cosecant. And you know how I know is because each of these has 1 co in the pair. There's the co in that pair. There's the co in that pair. And there's the co in that pair.
Oh, okay.
Okay, so cosecant has to go with sine because there's got to be a co in there.
Okay.
If I put secant with sine, there wouldn't be a co. So I know I got it wrong.
Right.
Okay? So there's a relatively easy way to remember your reciprocal identities. And of course, if sine equals 1 over cosecant, then cosecant equals what?
Secant.
Cosecant equals 1 over sine.
Ah, okay.
These are reciprocal identities. So if sine equals 1 over cosecant, then cosecant equals 1 over sine. What does secant equal?
1 over cosine.
And cotangent
Is 1 over tangent.
Okay. Those are the 6 most important identities that you need to memorize. Okay? There are a couple of others. There is the quotient. These are the reciprocal identities. What are the 2 quotient identities that they want you to know? Tangent equals something, and cotangent equals something.
Couldn't it be tangent equals sine of, or sine over cosine?
And cotangent would necessarily be what? Since it's the
Sine over
reciprocal.
sine.
Yeah, because it's the reciprocal. Which means the only one you have to memorize is this one. And the only 3 you have to memorize up here are these 3.
Right, because the other ones are just the
Other ones you can figure out. Okay?
Right.
So let's go on. There's 3 Pythagorean identities. The most important one, the one that they teach you the first, the one that they expect you to know for the ACT test, is this one here. What's that equal to? That's equal to 1. Always. No matter what x is. In
Right.
other words, if I said the sine squared of 47 degrees plus the cosine squared of 47 degrees, that's going to be 1. No matter what angle I stick in there, the sum of them is equal to 1. Okay?
Right.
And to be clear, let's make sure we know that this is different than this. That is not the same as sine of x squared. The one on the left is sine x times sine x. The one on the right is the sine of something squared. Whatever angle we would take, we would square it. We take the sine of that, which is completely different than taking the sine of that angle and multiplying it by the sine of another angle. So these 2 here, just be aware of. So that you don't have to memorize that. Just know that they're different. And you will rarely see the one on the right. You don't see that very often. Maybe not even until you get to calculus.
All right.
So just know what sine squared of x means is sine of x times sine of x.
All right.
Okay, there's another one you have to memorize. There's no other way to do it. These are Pythagorean identities because everything is squared. And they're all based on a right triangle and the fact that the sum of the sides squared equals the sum of the hypotenuse squared.
Right.
The tangent one is a little different. It's related to secant. And you add 1 to the tangent to get secant squared. Notice how different this one is than this one. Okay? So you have to memorize that one. You have to memorize that one. The third one they expect you to know, you don't really have to memorize it. It is the cofunction of tangent, and it is the cofunction of secant. Now, let's back up a little bit and talk about cofunctions. Sine is the cofunction of cosine. Tangent is the cofunction of cotangent. And secant is the cofunction of cosecant. Okay, that's what cofunctions mean. Different than reciprocals. Notice that the only one whose cofunction is also the reciprocal is the cotangent. The other two, that's different. Sine is the reciprocal of cosecant, but the cofunction of sine is cosine. So that's easy enough to remember. The cofunctions are the one where you stick a co in front of the word. So what's the cofunction of tangent squared? And in fact, what's this third Pythagorean identity going to be? If we have the cofunction of this plus 1 equals the cofunction of that. Joel, you still there? Joel, did I lose the audio?
Yeah. Can you hear me now?
Yeah, I can hear you now. I thought I lost you
there
for a
we go.
moment. Yeah.
I think it just glitched out. I couldn't hear anything you said for a little bit.
Okay. So what is, in other words, the third Pythagorean identity is the same as the second, only using the cofunctions of each. So what would the third one be?
Would it be? Crap.
What's the cofunction of tangent?
Cotangent?
Just stick the word co in front, and that's what the cofunction is. What's the cofunction of secant?
Cosecant?
So the third one, you don't have to memorize. Just know that it's the same as the second one, only using the cofunctions of each.
Oh, okay.
Okay?
Yeah.
So there are the 11. There's 3 Pythagorean. There are 2 quotient. And there are 6 reciprocal ones.
All right.
But you really only have to remember 3, 4, 5, 6 things. You only have to memorize 6 of the 11, and you can figure out the other 5. And that is the secret for memory. Now, when you use them often enough, you'll eventually memorize them on their own, and you won't have to use these little tricks. But when you're first learning trig, these tricks really help. The fewer things that you have to retain in memory or be able to recall from memory, the better off you are. Okay? So, now let's talk about trig functions of angles. Well, let's review the first quadrant, trig functions. You've had the unit circle, right?
Yeah.
When I'm working with somebody and just giving them introductory trig, this is always where I start. So, tell me what the sine of 45 degrees is. All of your first quadrant standard angles, which are 30, 45, and 60 degrees, all of those can be answered by memorizing these 2 triangles here. These triangles you've been working with for 3 years, all the way back to geometry.
Yeah.
The reason is that they're so fundamental to math, including trig. So the sine of 45 would be what?
Sine of 45 would be square root 2 over 2.
It would. You
Yeah,
didn't get
I'm good with the whole unit circle stuff.
Okay, so what's the sine of 210?
I'll have to sneeze.
Bless you.
Thank you. Sine of 210 would be negative square root 3 over 2.
No. What is its equivalent first quadrant angle?
30 degrees.
Okay, now what's the sine of 30 degrees?
Square root 3 over 2.
Opposite? 1
Oh, 1/2. Sorry.
over 2.
Yep.
And you're correct, the sign is negative because it's in third quadrant where only the tangent is positive.
Right.
Now this all students take calculus. This sine and cosecant. This really should say sine and cosecant. This should say tangent and cotangent. And this should say cosine and secant.
Right.
Because the reciprocals have to have the same sign on them as their reciprocal does. You can't take the reciprocal of a number and have it change sign. All right. So you're good with the unit circle. So no matter what angle I give you, if it's a multiple of 30, 45, or 60, you know what the thing is, right?
Yeah.
So what's the sine of 180 degrees?
Wouldn't it just be just 1? Negative 1.
Right there. 0.
0.
You need to
yeah, it's the other one.
probably need to memorize this graph. This graph is y equals sine x. You not only want to memorize it, but you want to memorize the points on it. That's 2 pi in radians. That's pi. That's 3 pi over 2. And that's pi over 2.
Pi over 2.
So when I said sine of 180 degrees, that's the same as pi. Just look at the graph. In other words, for your quadrangles, the quadrangles being the ones that are multiples of 90, those you can't really get from that, and you can't really get them from the unit circle. But if you know what the curves look like and how they're divided up, then you can figure it out. What's the sine of pi over 2? 90 degrees.
Pi over 2 or 90 degrees.
Each of these 4 points that I've broken up on the curve are the key points for this curve. In other words, right there is when it reaches its maximum of 1.
Right.
Right there is when it comes back through 0. Right here at 3 pi over 2, or 270 degrees, it goes down to its minimum, minus 1. And then it comes back to 0 at the end of the unit circle, or when you're back to your starting spot. So these 4 points, actually 5, because 0 is considered a key point, are critical for doing trig. You need to be able to graph that from memory, really. Not that hard. Just know that it starts at 0 and goes up, and that all of the key points go through these 4 quadrangles. This is 90, 180, 270, and 360.
Right.
All right. So, specifically, beyond that, what kind of stuff are you doing? In other words, have you gotten into solving triangles yet, using the law of sines and the law of cosines?
Not yet. I think that's the next part.
Okay.
But
Have you gotten into the sinusoid function, which is this?
No, not yet.
Okay. That's a hard part of trig that you guys.
Oh, that part, yeah, with the.
You guys might spend a
with the
week.
graph.
Yeah.
Yeah, with that. So yeah, we did that. We already took the test a while ago.
Okay.
It was pretty easy. I did pretty well on that.
All right. Let me quiz you on it because this is a very hard part of trig. There is a sinusoid function. Could you graph that if you had to?
Yeah.
A is equal to what?
3.
B is equal to?
2.
So what does that make the period of this particular function equal to? We know the period of sine x is 2 pi. But what's the period of this one going to be? How does B relate to the period?
The period would be the distance between, like, trough to trough.
Yes.
So it would just be 2.
Well, the period is actually equal to 2 pi over B. Since 2 is B, this period is pi for this function, which means that when I graph it, I've got to graph it and end at pi, right there.
Right.
So if I divide this up into fours, that would be pi over 2, that would be pi over 4, and that would be 3 pi over 4. Those are the 5 key points for this graph. But I'm not done yet. I just changed the period of the normal sine curve to reflect this particular B. Okay? So this is very critical here, this step right here. You can't make any progress at all on sinusoid functions unless you know that.
Right.
Okay, what is C?
C is pi over 4, which is the horizontal.
Plus pi over 4. And so what is the phase shift? Which way am I going to shift it?
Up.
A phase shift is left or right?
Left or right, okay.
Yeah, in other words, if I phase shift that sine curve by pi over 4, it would start it here, and it would look like this.
Right.
Okay? So the phase shift does not change the shape like the period did. The period of only pi changed the shape. It took my normal looking nice sine curve and it scrunched it up by a factor of 2. The phase shift merely moves it. Right or left. Right or left. A positive phase shift is right pi over 4. Finally, what's D?
1.
And what does that do to
It's vertical shift.
That's the vertical shift.
Moves it up 1.
And that also does not change the shape. Okay, so let's see how we would graph this. Well, the first thing I'm going to do when I graph it is take care of the vertical shift. In other words, I'm going to put a dotted line there to represent the new line of symmetry. Okay? I know that because I have an amplitude of 3, I've got to go up to 4 and down to minus 2. In other words, I got to go up 3 units from my base line of symmetry and down 3 units.
Right.
Okay? Now I know my phase shift. Let's start there. So let's start this curve right there, which is pi over 4. So where is the end of my curve going to come? In other words, if that's where it begins, where's the end of it?
Would it be Pi over 4?
Yeah, 5 pi over 4. In other words, I
Yep.
take my starting spot and I add my period to it.
Yep.
So this part here is 5 pi over 4. So I gotta draw my curve between those 2 points, and I split those 2 points up. This has to be 3 pi over 4. This must be 2 pi over 4. And this must be 4 pi over 4.
Right.
So now I'm ready to draw my curve. I'm going to start there. I'm going to reach my high point at the second key intersection point, right there.
Right.
I'm going to come back through the curve at the third key point. I'm going to go down and hit my low point at the fourth key point, and I'm going to come back to my starting spot at the fifth one. So now drawing it is just connecting the dots. And that's how you work a sinusoid function. Okay?
Yeah.
Now, another problem that it would be tough for us to work on would be if they give you the curves and they want you to come up with the sinusoid function. In other words, they want you to be able to go both ways on that. They want you to be able to take the equation and graph it, but they want you to also be able to take a graph, figure out what the equation is.
Right.
All
Yeah. Yeah, I understand that.
right, let's go on. What else have you covered? Have you covered the real-world problems with the sinusoid function, like a tides problem, or a Ferris wheel, or a water paddle, or breathing, or any number of other periodic events?
Yeah, we did the Ferris wheel stuff. Like if a Ferris wheel is 1 foot off the ground and you started measuring the cart when it was already at at 90 degrees or something like that.
Let's say...
I don't remember, but yeah, we figured it out. It took a while, but we figured it out. It wasn't. I mean, it really wasn't that hard when you looked at it. You just had to make sure you had.
The key thing for a Ferris wheel is how you come up with A and D.
Yeah.
So what is A? If my Ferris wheel is 24 feet high at the top and the bottom is 2 feet off the ground.
It's 22.
Well, how do I get A and D? A is the difference of these two numbers divided by 2, and D is the sum of these two numbers divided by 2. So A is 11, and D is what?
D would be
The sum of those two numbers divided by 2.
13.
Okay. So, in other words, that already tells me a whole lot in terms of the equation here.
Right.
I'm going to start at 13. I'm going to go up 11 to 24. I'm going to go down 11 to minus 2. So my function is going to look something like that, right?
Yeah. Mm-hmm.
Those are the two toughest parts of any real-life problem. Not toughest parts, but the parts that you want to remember. Is you get A from taking the maximum minus the minimum, divide by 2. You get D from taking the maximum plus the minimum, divide by 2.
Right.
So
You just have to make sure, the whole point of this is just to make sure that you have the A and D right.
Well, the next toughest part is B. Let's say that my Ferris wheel goes around 3 times a minute. We'll make it a fast Ferris wheel. 3 revolutions per minute. what is its period, and therefore what is B going to be? Let me help. 3 revolutions per 60 seconds.
Oh, so it just can be 20 seconds each.
20 seconds would be the period. So I don't know B yet, but I know my period. It's 20 seconds. So what's B? B is always equal to 2 pi over the period, or the period is equal to 2 pi over B, depending on what you're solving for.
So B would be 2 pi over 20.
Right, or pi over 10.
Right.
Okay, well now I almost have the whole thing solved. In other words, I've got y equals 11 sine maybe of pi over 10 times t, we're going to use time as a variable here, minus some phase shift, which I haven't figured out yet, plus 13. So I've got most of the function figured out. The only thing I need to figure out is the phase shift. So if the people get on the Ferris wheel right there, in other words, they walk up these steps and they get on right there, what's the phase shift going to be? And am I going to use sine or cosine here?
You would use sine.
Okay, and what's the phase shift going to be?
Wouldn't there be no phase shift?
Yes, very good. The reason there's no phase shift is, let's look at the sine function.
It starts at 13.
Starts out at the middle and goes up.
Right.
Well,
and so
that's exactly what these people on the Ferris wheel are going to do. They're going to start out at the middle, they're going to go up, and then they're going to come all the way down. They're going to go from 24 all the way down to 2. Here's 24, here's 2. So the fact that they start out in the middle, the exact middle, and go up means it fits that curve perfectly. So there is there's no phase shift. If they started down here and got onto the Ferris wheel right there, what would I do? What would I use? Because I have a choice here. I can either use sine or cosine, and either is correct. In other words, even in this example here where I used sine, I could have used cosine and come up with a phase shift that made cosine work.
Right.
But the key is to see what is happening. If I'm getting on here, what am I doing? I'm going up the full 9 yards initially. Well, what does that? The cosine doesn't do that. Cosine does this. But guess what does do that? The negative cosine. If I take the negative cosine function, it's just this reflected about the x-axis, right?
Right.
Well, the negative cofunction starts at the bottom, goes all the way up, and then comes back down and ends up at the bottom. Well, that's what these people on the Ferris wheel would be doing. They'd be starting at the bottom, they would go all the way up, and then they would come all the way down. That's exactly what this function does. What is that function? Y equals minus cosine of x. So if they're getting on the bottom, I'm going to make this a minus 11. Y equals minus 11, and I'm going to use cosine instead of sine. So just still no phase shift, because they're beginning at the typical place. They're beginning at the starting spot for the cosine function. There's no phase shift there. I'm starting at 2, going up to 26, coming back down to 2. Okay, So that's a pretty good problem to go over for real-life problems using the sinusoid function, this thing right here. Now, the one thing you have to be extremely careful with here is whether this 2 is inside or outside the parentheses. If it was inside, let me change just one aspect of it. And don't put it beyond them to give you this kind of a problem. What is B? I changed it and put it inside the parentheses. What is B? It's still 2.
Yeah, it's still 2.
It's still 2. It doesn't change that. What it changes is the phase shift.
Right.
Because I really need it. This is only the phase shift if this exponent is 1. So the first thing I would have to do, if I got this problem like this, is put the 2 outside the parentheses. Factor it out. Well, when I factor it out, it becomes sine of 2x minus pi over 8. Pi over 8.
Oh, yeah, because it's a fraction now. Okay.
When I redistribute, I got to come up with that. So
Right,
the phase shift changes if that coefficient is inside the parentheses, so you have to really pay attention to that. Always get it into this format as your first step. In other words, if there's a coefficient in front of that x and the parentheses are outside, remove that coefficient by factoring it out.
All right.
All right. Well, that's a quick once-over on sinusoid functions. And I do mean quick, because that, I'm sure you guys spent a week on that in class. That's a hard topic.
I think we did 2 weeks on that. But I did pretty well on the test. I think I got an 80 on it. But
good. Good.
So, I mean, it's not that bad.
What other kinds of problems can you think of? How about trig equations? Are you solving trig equations yet?
Like what? You mean
like the sine of theta equals 1/2. How do I solve for theta?
No, not yet.
Are you familiar with the inverse trig functions? Let's talk.
Yeah, we haven't done that. We've only been doing we've recently just been doing the identities. I mean, we did the trig circle first. We did the sinusoid graphs. Then we just finished going over the fundamental trig identities and stuff.
Okay.
So we're taking the test on it, and it's not that bad. I mean, I'll have the.
So you haven't. Yeah. We can certainly work off that, and I much prefer that, to be honest.
Yeah.
Because I don't know what you don't know and what you know at this point, and a review will highlight that. But just to clarify, because I kind of think you probably have had this. This is true if and only if that is saying the same thing as that. In other words, when we take the sine of an angle, we get a number.
Right.
When you take the inverse sine of a number, you get the angle. Have you had inverse trig functions at all? If you haven't, let's not talk.
We did that a long time ago.
Okay. All right.
Beginning of the semester.
But
so, I mean,
they're fairly critical for solving equations. If you've had any trig equations that you're solving.
I mean, yeah, I think I'll have the review for Friday because I scheduled one with you for Friday night. So
okay.
I'll have that by then. We can work off that. Is that better?
Yeah, absolutely, for sure.
All right, cool.
So, do you want to do anything the last 15 minutes here, or
yeah,
you just want to wait for Friday?
Yeah, I think we'll wait for Friday. I mean, I really don't have anything else to ask. I just want to go through that, you know what I mean, and see if I missed anything.
You still want to do it Friday evening? Is that the best time for you?
Yeah, because I'm going skiing that day, and I have family the rest of these days in between. So, we'll be back at around like 7, and so I need to unpack, and then I'll be able to sit down.
I got you. I
So,
got you. Don't be too tired.
yeah. I won't. Don't worry.
Have fun skiing, and I will talk to you Friday evening.
All right, no problem. Have a good day.
All right.